In this video, I'm going to show you how to create a material to make bubbles like these. Most of the work involves setting up the shader nodes to create the rainbow effect and the random appearance. In order to get the bubble texture to look right, it needs to be random, and in order to do that, I use a noise texture. The other thing is that you need the color pattern, essentially a rainbow effect, to repeat over the surface of the bubble. You don't want it to just happen once. If you want, you could do that. You would just have to pick the right scale. But this method allows you to choose how often the rainbow pattern repeats. And what I do is I take the output of the noise texture, the factor output, you want the black and white, and I multiply it by 3. I do this in order to get the range of values that I need to get the full range of color out of the color ramp. Then I take that multiplied value and I feed it into a modulo node, or a math node, where I do a modulo 1, and this ensures that whatever I multiply the output of the noise texture by, the value that I feed into the color ramp is no larger than 1, so that the output range is 0 to 1, and that gives me the full range of colors from red to purple and all the way up to red. This multiply value is key. If you use a value less than 1, you will not get the full range of colors. You might get up to, if you use a value of 1, you might get a range of colors up to light blue. If you use a smaller value, you get an even smaller range. You want to keep the modulo at 1. There's really no reason to use anything any larger than this. Is no good, because you'll get values bigger than 1 going into the color ramp, and that doesn't do anything. If you use a value smaller than this, you're going to be restricting the range of colors that you get out of the color ramp. So you want to keep this at 1 and then just play around with the multiply. The multiply also affects how often the rainbow effect repeats over the object. If you use a large value, you'll get a bunch of repeats. If you use a small value, you get less repeats. The scale of the noise texture basically affects only the size of the random pattern on the bubble. It does not affect how often the rainbow effect appears over the bubbles. If I turn on the render, you'll see what I mean. Let me turn down the that's good. Okay, what happens is, if I use a scale of, let's say right now I'm using a scale of 6, if I use a scale, let's crank it up to 10, what happens is the scale of the pattern goes way up, and it's very hard to see because now I have the color changing very rapidly. So what I need to do then is turn the scale on the noise texture down in order to be able to see that again. And as you can see, the pattern is larger, but I get more repeats over that same pattern. So I get a multiple number of red to green to blue to red. So if the multiply is large, you're going to have to turn down the scale on the noise texture down. If the scale on the noise texture is large, you're going to have to turn the multiply down in order to be able to see the pattern. Turn that back down to 3. Okay, once I've done the math, of course you feed it into a color ramp where you've spaced the color stops evenly across the ramp at intervals of 0.166, and you want to use the colors red, yellow, green, cyan, blue, magenta, and red again. That way you get the full range of colors. You then take that and you feed that input into a transparent node and a glossy node. And then you feed that, then you take those outputs and add them together using an add shader, not a mix shader. You want to add these two together so that you get the full brightness of both of them together. Then you mix those two, well, you mix the output of the add shader with a transparent shader that is set to white using a mix shader. The factor of the mix shader is then controlled by these nodes here, where I use a layer weight node to generate I use a layer weight node to generate the shading of the color from dark at the edge to light in the center. And then I adjust the rate of that shading using a multiply node where I take the output of that, multiply by 0.8 and add 0.2. And what this does is it allows me to get some color in the center of the object, whereas if I use an add value of 0 here, for example, then I get a fully transparent center part like I do here. Like you see in this bubble here, you barely see color around the edge. Even when I change this to 1, if you use the output of the layer weight node directly, you don't really get much color in the center unless you turn this value way up around 0.5. And then you get a bubble where it's bright colors around the edge and pretty much no color in the center. That's what the add does. The add will give you at least some value, some color in the center of the object. 0.1 might be a little low. You might want to use a 0.2. 0.2 value gives you a good amount of color in the center. If you do that, you might need to turn down the blend factor, because now the edge of the bubble becomes very saturated and dark for color, so you want to probably turn this back down to 0.2. So this range of values gives you a good simulation of a bubble. Some cases you might want to turn down the scale, might be a little bit too big. Turn that down to 2. Because on most bubbles, the rainbow pattern doesn't repeat that rapidly. It tends to be a very slow transition from one color to the other that takes over a large distance of the bubble. Something like this, maybe. Like I said, that's why you need to play with the scale factors and the multiply to get something that looks like what you want. You can replace this transparent shader by a refraction shader, and that'll give you refraction. That will make the object, instead of looking like a bubble, it'll look like a drop of water. You can use that if you want to create like a puddle of water with an oil sheen on it. You want to use a refraction shader instead of a transparent shader. Otherwise it'll just look like, if you use the transparent shader for a flat surface, it'll look like colors floating in air. You want to get the effect of the refractive index of the water that's in the puddle. Another way to generate the pattern is, instead of using a color ramp to produce the range of colors, a rainbow transition, is to use 3 noise textures, multiply the factor by red, green, and blue. You probably want to use different scale factors for these so that you get more of a variation. Probably also have different distortion factors on them. Add the outputs of the 3 colors together. Feed them into a hue and saturation value node and crank up the saturation to maybe 3. And then you feed this into the transparent node that's being added to the glossy node. And the same thing, you add that color to the glossy node. So now you've got that color going into the transparency node and the glossy node. And what happens is you get a more random color effect. Here, what I've gotten is the colors are kind of blue, probably because I don't have a high enough scale in some of these colors. Probably want to turn up the scale on that. If I turn it up to 8, what do I get there? Now I'm getting like yellow and purple. The effect is different and the colors are less saturated. This might be too big. Turn that down to, let's see what happens if I turn that down to 2 there. And 2 there. And 2 there. I see how the different scales affect the color output. When I had this at, what was that, 8? When I had that at 8, you get more colors. When I have it less, when I have it smaller, you get less colors. You might also want to multiply the output of each one of these by 3 in order to get more of a range, because I found that the noise texture output isn't 0 to 1. It tends to be between 0.3 and 0.7, so you're not getting the full range of values that you need to get a good range of colors here. That also depends on the scale and the distortion. So you want to play with those values to get the color that you want. The way this comes out, I'll do a quick render of this. Let me turn that down to 50 and render this. What does this look like? Here I did a render of what that looks like, and you can see here the difference between the two methods of generating the pattern on the bubble. The original method, the first one that I showed you, produces the pattern here where you have essentially a smooth transition of colors like in a rainbow, and this method where you're just mixing the 3 different noise textures together gives you a random effect which kind of looks like a colored cloud effect on the surface of the bubble. It really depends on what you're trying to accomplish. I think the random effect actually looks better. It's more interesting to me in terms of visual characteristics. This one looks more like an actual bubble where the colors slowly transition from one color to another rather than this very random effect where you might get like orange next to blue, which will not happen in the rainbow effect. In the rainbow effect, you'll have a transition from one color to another. You won't have colors, widely different colors right next to each other. It all depends, like I said, on what you're trying to accomplish. So basically, the thing that controls the pattern most is both the scale of the noise texture and the multiply that you use on the output of the noise texture. These two work together to control the rate at which the color pattern changes and how tight the pattern is. Other things like the blend value for the transition from bright colors at the edge to faint colors in the middle, you can play around with the value here for the layer weight node. You can also use the Fresnel or Fresnel output instead. This gives you a very sharp edge instead of a... This will give you a very bright edge and a very faint interior, producing a more rapid transition from the edge to this dim interior part. I think the facing output probably produces a better transition. It's better to have a smooth transition from bright colors at the edge to faint colors in the center than it is to go from a very bright edge to a constant color brightness throughout the rest of the bubble. A way you can randomize the patterns on the bubbles so that each bubble has its own pattern is to take an object info node take the randomize output out of that node, multiply it by some number, and then add another value to it. What this does is it will give you a range of values between whatever the add value is plus whatever the multiply is. In this case, I'll get a range of values between 1 and 5. You then take this output and feed it into the scale of the noise texture. This will give each bubble its own scale. You don't want this range to be too big, because then some bubbles will have a very large scale where the pattern is very doesn't change very much over the surface. Other bubbles will have a very large scale and the pattern will change very rapidly, and that will, I don't know, that won't look realistic. It'll look kind of weird because some of the bubbles will just stand out too much compared to the others. You want to have this value range to be pretty small. I would recommend maybe 2 or 3, maybe no more than 3 really. You can also take this value and add it to the multiply, to the bottom input of the multiply that's used to multiply the color output of the noise texture. So that way not only will the pattern, the scale of the pattern change, but the rate at which the rainbow pattern takes effect also changes. It's probably a better idea to leave this turned off, to leave this at a fixed value like 3 or 4, because if this value again becomes too high, then the patterns will change too rapidly, and at the same time that the scale gets smaller, and so the pattern starts to look too noisy. Let me do a quick render so you can see what this does to the bubbles. And you can see here what the effect is. On this bubble here, the scale factor is small, so that the pattern is very large and you have a very slow transition from one color to another. On other bubbles, the scale is a little bit higher, so that the pattern changes more rapidly. If the output of this was also put into the multiply node that multiplies the color value, this would on these bubbles here, the rainbow effect would also increase, and so these would become much noisier. That's why I say it's better to leave this at 3 or a fixed value and not have it be affected by the random value that you get from the object info node. Another thing you can do to get more variety in the textures is to first add a texture coordinate node, then you want to take a mapping node and then you want to find, where is the vector, here we go, vector math. I'm going to take a vector math node, and what you want to do is you want to add the generated output of the texture coordinate, let's put that down here, to the location output of the object info node, feed that into the mapping node, feed the output of the mapping node into the noise texture, set the mapping node to texture, and now what you'll get is, since every bubble is at a different location, the texture will be shifted in whatever in some direction based on the location, the position vector of the bubble. So as long as the bubbles are not right on top of each other, each one will get a different offset into the mapping node to give you a different output and a different texture coordinate, so that the textures are offset by whatever the position vector is, and each one will have a different texture. So you can combine all of these things to increase the variety. You can combine, the multiply with the add, and then you can animate everything by changing the scale. So yeah, you can combine all of these things to give you a wide variety in the appearance of the bubbles. After fiddling with the values, I turned down the the multiply on the random, and actually I left the multiply on the random at 2. What I did is I turned down the add on the random, so now I'm getting a scale value between 1 and 3, and this is what you get. You get a pretty good variation on the bubbles. The texture coordinates changes the texture so that each bubble has a different appearance. The scales are also changing, but not very much. So some bubbles have a very gentle transition from one color to another. Others are a little bit more rapid, like these here. So yeah, just play around with all these different settings, including the fade, the facing output of the layer weight node, these values here. There's just so much variety that you can play with. I mean, you could even play around with the range of colors in the color ramp if you want to restrict it to there's just so much flexibility in getting the appearance that you want that it works out really well. The problem with using the location and adding it to the generated texture coordinate in order to produce a different texture for each bubble is that the texture will change as the bubble moves. And if you want that, that's fine. The problem is that if the bubble moves rapidly, the texture changes rapidly, and that's not going to look as good as if the texture changed slowly. So what you can do instead is you can use the randomize output and add that to the generated. What that'll do is it'll treat the random number that you get out of this as a vector of that points in one direction with all the same values. So in other words, all the x, y, and z's will be the same because you're using the same number for both the x, y, and z coordinates. So this will vary from 0 to 1. These values will be shifted from 0 to 1 in both the x, y, and z. So that may not be enough of a difference between some of these in order to give you enough variation. So what you can do is take the random number and multiply it by a large value. In this case, I don't want to use the vector add, I want to use a regular math node. And you want to take that, let's say multiply by 100, and then add that to the generated output. And what will happen now is the difference between the textures will be very different. This avoids the problem of the random number. Since the random number is 0 to 1, if the values are close together, the textures will be very similar. But by multiplying by 100, this increases the difference between the texture by a huge amount, so that the odds that any two bubbles will have the same appearance will be very, very small. Let's see what else you can do. Oh, another thing is, after playing around with this multiply value, what I found is that if you use a value of 3, you tend to get a range of colors that's a little narrow, so that you end up seeing mostly, in this case, light blue. You're seeing mostly yellows to purple, which is from here to here, or even not even that purple, mostly blue, or even light blue, green to blue. So you're seeing a narrow range of colors if you multiply by 3. It's probably better to multiply this by 6 and try to keep the scale in the noise texture at a low number. In this case, I'm taking the random output, multiplying it by 0.5, and adding 0.5, so that the value of the scale is it's not very much, not much of a range. It's 0.5 to 1, so you could always, get rid of this altogether and set this to 1 or 2. You want to, don't want this value too big, because if since this is 6, you want this to stay at a pretty low value. Probably 0.5 is better, so that the color variation is a little bit larger. If the color variation is too rapid, the texture starts to look very noisy. If I increase the scale to 2, you'll see what I mean. You get a lot of colors that the color change is very rapid, and from a distance the colors will start to blend together and the bubble will start to look white. So you want to keep this at a low value, and if you want to randomize it, I would, like I said, keep the multiply and the add to some low value. Also, a good value for the distortion is somewhere around 2 or 3. If you turn up the distortion again too much, then the texture becomes very jumbled up, and you have the same problem that you have if you turn the scale way up. So you don't want to have this too big. Probably a value of 2 is good, and this gives you a reasonably smooth gradation of colors, where the color bands are large and they're easy to see even from a distance. You can tell that those colors are unique to each bubble. At least the pattern is unique to each bubble. What else? I think that was the only thing. The only other thing I wanted to add. Yeah, there was nothing else. Oh, what you can do is, instead of using a color ramp, is use a hue saturation node. And what you do is you just feed the output of the modulo node into the hue of the color ramp, and then feed the output of the color into the 3 nodes that are being used for actually giving the bubbles a specific color. Now, what the situation here now is, you see that the bubbles are white because because you need to start with a very saturated color, and white is totally unsaturated. So what you want to do is you want to start with cyan. Give me that. There you go. The hue does not work on white, so you need to start with some saturated color. What are these? Oh, I wanted to be cyan. Okay. So now what happens is, as this value goes from 0 to 1, the hue is going to vary from 0 to 1. So it's going to take this light blue and change the hue of it to every possible color from light blue to red and to purple, whatever. All the other colors will get generated. Now this may be a little bit quicker to run as far as the time it would take to draw the texture. The advantage to this is that you can play around. You can also randomize the value. You can also randomize the saturation, so that you can do things like this. So now the color changes into saturation. You could use a random value. You could take the randomize out of here and throw it in there, and now each bubble will have a different saturation or a different value, so that you can change the appearance. This is not going to look right on a bubble, I mean, as far as realistic bubbles, because the rainbow effect on a bubble is saturated, is 100% saturated. It is not going to be a partially unsaturated color because of the way interference works. What else? I think that was it. Oh, the advantage to using a color ramp is that you can choose what colors the order of the colors in the color ramp. With this, you pretty much have to use the colors that are in the rainbow, from red to magenta. So this gives you the additional flexibility of being able to choose the bands that you're using. So it's probably a good idea to play around with one, with one or the other, and figure out which one takes less time to generate the color. I suspect that the hue saturation value is probably quicker in terms of calculations. That was the only other. I think that was the only other thing that I thought of that affected the response. That affected the. It was the only other thing that I could think of that affected the appearance of the bubbles. This here that I added this in order to reduce the amount of caustics that are generated from glossy surfaces. What it does is, if the bubble gets hit by a diffuse ray, a ray that has bounced off of a diffuse surface, it tells the ray that it's not seeing a glossy surface, that it's seeing a diffuse surface. By using this mix shader, it tells it, well, if it's a diffuse ray, tell the ray that it's a diffuse surface, not a glossy surface, because caustics or fireflies are caused by a glossy bounce after a diffuse bounce. I think, yeah, that's right. So the ray bounces off a diffuse and then hits a glossy surface. That causes a caustic on a firefly on the diffuse. So by doing this, you tell it that it's not a glossy surface, it's a diffuse surface, but only if it's a diffuse ray. If it's any other ray, it treats it as if it were a glossy surface. And what this does is it allows you to maintain the color that the surface has, because I'm using the same color as the glossy, but it gets rid of the firefly effect and reduces the number of fireflies significantly. It works very well.